Okay, number 10 says graph to solve. So when we graph and solve, that means that we take each side of the equation, set it equal to y, and graph that part. So y equals 0. I just graphed there. Now I need to graph the right-hand side of the, or the left-hand side of the equation. Y equals. That matches y equals ax squared plus bx plus c with an a value of -1, a b value of -3, and a c value of 4. Now when it's in standard form, the c value actually tells you the y-intercept, so I know there's a point right there at 4, because if you plug in 0 for the x's, you get 0 minus 3 times 0, which is 0, plus 4, which is 4. So I know that point. So that's helpful, is that the c value gives you the y-intercept. So that's really all I need the c value for. The a and b value are going to give me the vertex. We use the formula -b over 2 times a. In other videos, I show where that, or talk about where that comes from a little bit. So for this problem, -b is -3, or the opposite of b is +3. 2 times -1 is -2, and so I have a vertex at -1.5, because 3 divided by -2 is -1.5. My y value then is going to be that -x squared as like a -1 times x squared, so -1.5 squared, minus 3 times -1.5 plus 4. So I'm going to pause and use my calculator. So if I do that in my head, I have to use fractions and things, and I don't want to do that right now. So -1 parentheses -1.5 squared outside the parentheses, minus 3 parentheses -1.5, and then add 4. And I got 6.25 for the y. We'll see if this works in a moment. So my vertex is at -1.5, 6.25, which is not ideal, but we can see if it works. -1.5, 6.25, 1, 2, 3, 4, 5, 6, and a little bit. The touch on my smartboard is not precise, so that's a little bit off. But -1.5, comma 6.25. I do have a -1 in front, so I'm going to go down 1, then down 3, then down 5 from that point. And I'm going to have to estimate a little bit since I'm at 6.25. When I go over 1, I'm going to go down 1, I'll be at 5.25. From there, when I go over 1 and go down 3, I'll be at 2.25. And then when I go down 5, those are not high enough really. That would be my graph. So let's see if I draw those. My solution would be where they intersect. They look like they intersect at -4 and at 1. And I can check that by plugging those into the equation, the original equation, and see if I do get 0. So I'll do that underneath here. If I said -1 times -4 squared minus 3 times -4, and then add 4. This beginning is going to give me -16, and then I'm going to have a plus 12 plus 4, and that does equal 0. So -4 works. If I plug in the 1, I think that'll also work. So when we solve by graphing, we graph both sides of the equation and then find where they intersect.